Hi, it's Raj Bapala, co-founder and CEO of Applaa. As a parent, we want to give the best experience for our kids. I've got two kids, 11 plus, and other one is doing GCSE exams. So we've spent a lot of time and a lot of money for tuitions, 40, 50 pounds a class and math, science, and English, and many things. And also we've tried our platforms and people saying, okay, use Atom Learning, iExcel, and this and that. And they're okay, but at the end of the day, you're paying 40, 50 pounds for them, and it's really not working out. It's just like only one, and again, where do you go for the next, right? And it's just like a simple mock exam practice, it's there are so many things you can do. It's not really a comprehensive feedback mechanism tool, right? That's what I think. I got really frustrated with all these tools, and again, spending with teachers and tutors is not really working out. So here, that's why we built Appla with the vision of actually helping kids as early as, like from year 8 years onwards to all the way to the GCSEs. We've got the whole curriculum built. Again, we've digitalized the whole UK curriculum here. So, and actually we're giving a value only 9.99 a month, 10 pounds, right? What is that? Is the cost of a pizza, even less than that. And so we want to give that a best experience for everyone. You can really see from year 4 to year 11, they can see every single subject, math, they can able to look at this lesson. They can practice but understand the concept first rather than writing an exam for the sake of writing. And then you can able to do a lot of practice also. Then, what is this thing? And then you can see the assessment and whatever you wanted to do. And you can do a lot of things again each year, year 4, year 5, year 6, all the way to there, right? And that's about it. And also you can, once you have there, then probably, most people will go for 11 plus, which obviously you can really see. And yeah, so we have built a comprehensive 11 plus past papers, around 5 dozen papers we have. And again, four topics: verbal, non-verbal, math, and English. So you can able to see pretty much everything. You can take exams. Also, you can get the feedback. Also, you can see how many exams you've been taking. And these are the exams I've been taking verbal reasoning, and also you can really give the feedback by the subject, by lesson, and at least it will give you a really great feedback for the parent and also teacher for obviously if he's having a teacher and also parent and the kid for writing them as well. You can do quite a lot of things as well. So an example, let's take an exam for verbal reasoning. So you can really see that it actually I did an exam math for now before it actually tells you where you got right, where you got wrong. It's really great, right? As a parent, you cannot able to tell, what is the correct answer, right? So you can able to do, and it's brilliant, isn't it? So it just saves a lot of time. A lot of institutions are charging 40, 50 pounds, even for a paper sometimes, cost like that. And we're giving for free 5,000 questions, right? And many unlimited questions and papers they can do, all for 9.99, and they can do practice again if you want to do it. Just simply go and write an exam, and you can able to see submit papers. You can directly see as well, and the results coming through. As an example, let me go back and show the exam as well. So if you see some of the exams what I've done just now, you can see that exam coming through as well. You can really see the results. So it's just brilliant way to actually get the feedback as well as assessments for the kid who is writing the exam and studying, as well as for parents not to spend too much time for them to sit with them and write down exams, and also more importantly the cost. And we'll explain a lot also all of this in subsequent videos. You can also see that as well. I really trust this is valuable, and take advantage of this offer. It's only 9.99, which is a significantly lower cost. Anyone can able to afford it. It's a cost of a small pizza these days, and compared to 40, 50 pounds a tuition class. And I truly trust this is helpful for you. And yeah, sign up at applaa.com/UK, applaa.com/UK, and register for free. And it's 1 month free as well for you guys. So make use of it. And if you're writing the 11 plus exam, all the best. And again, we'll explain further details also in the subsequent videos. Thank you for watching.
Welcome to Probability. Let's understand chance and outcomes. We will cover likelihood, tree diagrams, and expectation, and finish with Venn diagrams.
Welcome to this explainer. Probability really isn't just some random game of chance. Actually, it's a highly logical, completely predictable mathematical toolkit. If you've ever felt like randomness was just impossible to pin down, well, today we're looking right under the hood to see how chance actually works.
So it begs the question, can the totally chaotic world of rolling dice and flipping coins actually be organized into clear, actionable data? The mathematical answer is a resounding yes. Chance isn't just magic, right? It has a structure, it has rules, and most importantly, it has a measurable scale. To get there, we've got a clear progression for this session. We'll be breaking things down into 5 bite-sized pieces: understanding basic likelihood, mastering combined events, navigating with tree diagrams, calculating expected frequencies, and visualizing with Venn diagrams. Let's jump right into the first one, understanding basic likelihood, which is really the absolute foundation of chance.
The absolute crucial takeaway here is that all probabilities exist strictly on a scale from 0, meaning completely impossible, to 1, which means absolutely certain. Think about rolling a standard 6-sided die. Getting a 7? That's a 0. Impossible. Getting a number less than 7? That's a solid 1. It's certain. And right smack in the middle, at 0.5, you have a totally even chance, kind of like flipping heads on a fair coin. Literally everything happens somewhere between 0 and 1.
At the core of all this is a remarkably elegant equation. We are simply mathematically comparing what we want to happen against everything that could possibly happen. It's just the number of favorable outcomes divided by the total number of possible outcomes. It's a beautifully simple way to frame uncertainty, don't you think?
Let's put that formula to work. Say you roll that standard die, and you really want a 4. Well, there's only one 4 on the die, right, out of 6 possible sides? So one favorable outcome divided by 6 total possibilities gives us our clean, simple fraction, 1/6. Honestly, once you nail this basic calculation, you basically unlock the whole shebang.
Okay, moving on to our next piece, mastering combined events and calculating multiple outcomes. As things get a bit more complex, we have to clearly separate our concepts. For instance, tossing a coin and rolling a die. Those are what we call independent events. Why? Because the coin has absolutely no memory. It has 0 influence over the die. Whether that coin lands on heads or tails changes absolutely nothing about how the die is going to land. They happen together, sure, but their probabilities, they act completely alone. Let's calmly walk through the multiplication rule for these independent events. If we want the combined probability of getting a head and then a 6, we just multiply. The probability of a head is a half. The probability of a 6 is a 1/6. Simply multiply that half by that 1/6, and boom, you get 1/12. A great rule of thumb here: whenever you hear the word "and" with independent events, your brain should immediately think multiplication. Now, as scenarios get even trickier, we need a reliable visual framework. That brings us to part 3, navigating with tree diagrams and mapping the paths. When sequential events start piling up, trying to keep all that math in your head gets really tricky really fast. Tree diagrams systematically map out every possible outcome for you. Say you want to figure out the odds of getting 2 heads in a row. You start on the left, branch out for that first event, heads or tails. Then from the ends of those branches, you branch out again for the second event. Following a path from left to right lets you clearly trace outcomes like heads-heads or heads-tails, making absolutely sure you never miss a possibility.
Let's pause for a second to highlight a golden rule here. This is literally the secret to mastering these diagrams. Always multiply your probabilities as you trace along a single path. That's the AND rule we just talked about. But if you're looking at an outcome that could happen in a couple of different ways, you add the probabilities of those completely different paths together. That's your OR rule. Multiply along, add across. Definitely keep that golden rule in your back pocket.
All right, moving right along to section 4, calculating expected frequencies to essentially predict the future. So how do we actually use this math to make predictions in the real world over a long period of time? We use expected frequency. It's just the probability of an event multiplied by the total number of trials. Fun fact, this is the exact math casinos and insurance companies use every single day to forecast their long-term outcomes.
To put that into perspective, imagine an event has a 1 in 4 chance of happening, a probability of 1/4. And let's say we decide to run that trial exactly 40 times. What should our data look like at the end of that experiment?
Step by step, you just multiply that 1/4 probability by the 40 trials, and we logically expect the event to happen 10 times. And here's where it gets really fascinating. If you run the experiment in real life and get a number wildly different from 10, well, the math is basically whispering to you that the event might be rigged. For our 5th and final section, we're going to look at organizing messy data. So, visualizing with Venn diagrams. In the real world, events often share common ground. Imagine a school surveys 200 pupils and finds 80 attend drama, 60 attend science, but 30 actually attend both. A Venn diagram beautifully untangles that mess.
The overlapping intersection handles the and scenarios, while the union of the circles handles the or. It takes confusing overlapping word problems and turns them into a super clean visual map. To quickly summarize our session today, by layering these 5 core concepts, we've built a really robust mathematical toolkit. We mapped likelihood from 0 to 1, calculated combined events, traced sequential paths with trees, projected expected frequencies, and finally, untangled overlapping data. You now literally have the power to organize the chaotic world of chance into clear, actionable data. Master this probability toolkit, and you absolutely build your confidence. You no longer have to just guess at the likelihood of things happening. You have the precise rules and equations to calculate them for sure. So now that you've transformed chance into certainty, where will you apply this newfound analytical superpower in your daily life? I mean, look around you. The weather forecasts you check, the sports statistics you argue over, financial risk assessments, it is all built on the exact concepts we covered today. So what unpredictable event will you mathematically measure next? Thanks so much for joining me for this explainer, and definitely keep exploring the fascinating math all around you.